Tonight, we unveil a cosmic enigma that's rewriting the rules of our solar system. Neptune, the farthest planet from the Sun, is not what we thought it was. New revelations from cutting-edge telescopes have peeled back layers of mystery, exposing a world so bizarre it challenges everything we know about planets. Buckle up for a journey to the edge of our cosmic neighborhood, where the ice giant is stirring up a scientific storm. Neptune has always been the elusive outsider, a distant blue dot discovered not through a telescope's lens but through the power of mathematics. Back in 1846, astronomers noticed Uranus wobbling in its orbit, hinting at an unseen force. Calculations pointed to a massive body tugging at it, and there it was, Neptune, a gas and ice giant lurking in the frigid outskirts, 4.5 billion kilometers from the Sun. Since then, our knowledge of this planet has relied on sparse data. A fleeting 1989 flyby by Voyager 2, which snapped stunning images of a deep blue world with raging storms and winds clocking over 1,300 miles per hour. Those snapshots painted Neptune as a dynamic, icy giant, but they barely scratched the surface. Now, fresh observations are turning that picture upside down, revealing a planet far stranger than we ever imagined. The breakthrough comes from the James Webb Space Telescope, paired with advanced Earth-based observatories which have zeroed in on Neptune with unprecedented clarity. What they've found is nothing short of astonishing. Neptune's interior isn't the neatly layered structure we expected: a rocky core, an icy mantle of water and ammonia, topped with a gaseous envelope. Instead, it's a chaotic jumble of churning zones, some behaving like plasma, others inexplicably warm despite the Sun's feeble reach at that distance. These warm patches defy logic. Solar energy is too weak to heat Neptune's depths, and unlike Jupiter or Saturn, there's no significant tidal pull from nearby moons to explain it. Something inside the planet is generating heat, and it's throwing our models into disarray. Picture this. Deep beneath Neptune's swirling blue clouds is a turbulent dance of materials unlike anything we've seen. Scientists are now pointing to the possibility of superionic ices, exotic substances where water molecules break apart under crushing pressures, forming a slushy, electrified mix that's part solid, part liquid. These ices could be moving in vast conveyor-like currents, stirring up turbulence and producing heat in ways we don't fully understand. It's as if Neptune is hiding a cosmic engine, driving processes that make it glow warmer than it should. This isn't just a tweak to our textbooks. It's a signal that we might need to rethink how planets like Neptune even form. Then there's Neptune's magnetic field, which is acting like nothing else in the solar system. We've known for decades that it's oddly tilted, offset from the planet's center by nearly half its radius. But the latest data shows it's not just tilted, it's unstable, shifting and reforming in cycles that defy our current understanding of planetary dynamos. On Earth, our magnetic field comes from a spinning, molten iron core. Jupiter's comes from a layer of metallic hydrogen. Neptune might be powered by those strange superionic ices undergoing chemical reactions under intense pressure, creating charged flows that twist and reshape the field. Some researchers are even whispering about a wild idea. Could Neptune have pockets or cavities inside, acting like resonant chambers that amplify these electromagnetic quirks? It's a theory that sounds like science fiction, but the data is starting to back it up. These discoveries don't stop at Neptune's interior. The planet's atmosphere is throwing curveballs to its winds, already the fastest in the solar system, scream at supersonic speeds, tearing across the planet in ways we thought were driven by the Sun's distant heat and Neptune's rotation. But new evidence suggests something else entirely. Internal thermal pulses, bursts of energy from deep within, might be fueling these storms. Imagine a planet where the weather isn't just shaped by the faint sunlight trickling in but by violent, internal upheavals. If true, Neptune would be the first planet we know of where weather is primarily driven from within, not from above. This alone could redefine how we study planetary atmospheres, not just here but across the galaxy. And then there are the radio emissions, strange, irregular signals picked up from Neptune's depths. Unlike the expected hum from its magnetic field interacting with the solar wind, these signals seem to come from far below the cloud tops. Their frequencies don't match any known atmospheric patterns, hinting at processes we've never seen in nature. Some scientists speculate these could be tied to quantum-level reactions in Neptune's high-pressure core, or even entirely new chemical behaviors under its extreme conditions. It's like listening to a cosmic radio station broadcasting something we can't yet decode. Why does this matter? Because Neptune isn't just a distant planet, it's a key to unlocking the history of our solar system. Scientists believe Neptune didn't form where it orbits now. Billions of years ago, it likely migrated outward, its massive gravity sculpting the Kuiper belt and jostling the orbits of other planets. Some theories even suggest it helped eject a long-lost fifth giant planet from our system. If Neptune is as chaotic and complex as these findings suggest, the story of our solar system's youth might be wilder than we ever imagined, a tale of cosmic collisions, migrations, and chaos that shaped the worlds we see today. But the implications stretch far beyond our cosmic backyard. Out there, among the stars, Telescopes like Kepler and TESS have spotted thousands of planets roughly Neptune's size, dubbed mini-Neptunes or sub-Neptunes. These are some of the most common types of exoplanets in the galaxy. Our own Neptune is this different from what we assume, potentially with superionic ices, internal heat, and a shifting magnetic field, then those distant worlds might be just as strange. Everything we thought we knew about their composition, their atmospheres, even their potential to host exotic forms of life, could be wrong. This discovery doesn't just rewrite Neptune's story. It forces us to rethink how we classify and understand planets across the universe. What's driving all this? The answer lies in the tools we've built to peer into the cosmos. The James Webb Space Telescope, with its ability to capture infrared light and see through Neptune's hazy atmosphere, has been a game-changer. Combined with Earth-based arrays that stitch together data from multiple telescopes, we're seeing details Voyager 2 could only dream of. These instruments have turned Neptune from a blurry blue speck into a world of vivid complexity, revealing patterns we couldn't detect before. It's a reminder that our understanding of the universe is only as good as the lenses we use to see it. Let's zoom out for a moment. Neptune's quirks aren't just a puzzle for astronomers, they're a challenge to how we think about planets altogether. For centuries we've slotted celestial bodies into neat categories: rocky planets like Earth, gas giants like Jupiter, ice giants like Neptune. But what if Neptune doesn't fit? Its internal heat, its chaotic structure, its bizarre magnetic field. Some researchers are even wondering if it sits in a gray zone. Not quite a planet, not quite a failed star like a brown dwarf. This idea, while still on the fringes, hints at a universe with far more variety than our models allow. Neptune might be part of a whole new class of worlds, ones that blur the lines between categories and demand we rethink what a planet can be. This isn't the first time Neptune has surprised us. When Voyager 2 flew by, it revealed a world of storms bigger than Earth, winds faster than anything we'd seen, and a faint, delicate ring system we didn't expect. Now, decades later, we're learning that those were just the opening notes of a much bigger symphony. Neptune is a planet in constant flux, a chaotic system that somehow holds itself together, driven by forces we're only beginning to grasp. It's a humbling reminder that even in our own solar system, there are worlds we barely understand, waiting to append our assumptions. The deeper we look, the more questions arise. Could Neptune's superionic ices be creating currents that power its magnetic field? Are those warm patches evidence of chemical reactions we've only simulated in labs? And what about those radio emissions? Could they point to processes so alien they don't exist anywhere else in our solar system? Each answer leads to a dozen new mysteries, pulling us further into Neptune's strange world. For scientists, this is a call to action. The data pouring in from JWST and other observatories is just the beginning. Future missions, perhaps orbiters or probes designed to study Neptune up close, could confirm these findings and uncover even more. Imagine a spacecraft diving into Neptune's atmosphere, measuring its winds, mapping its magnetic field, and sampling its exotic ices. The technology to do this is within our reach, and the discoveries waiting on the other side could redefine planetary science for generations. For the rest of us, Neptune's story is a testament to the thrill of exploration. It's easy to think we've mapped every corner of our solar system, that the big discoveries are behind us. But here's Neptune, a planet we've known for nearly 2 centuries, still hiding secrets that challenge our best theories. It's proof that the universe is bigger, weirder, and more wonderful than we can imagine. Every new image, every strange signal, is a step toward understanding not just Neptune, but our place in the cosmos. So what's next? Astronomers are already planning follow-up observations, using JWST to track Neptune's